So now we've finished this atomic structure revision sheet, so that was our last video, we need to have a look at some past paper questions linked to this knowledge, just to check that we understand it. So let's have a look now, and we'll start over here. I'm going to use my trusty highlighter to help me during this. I'm going to answer as many questions as I can. So let's start with this. Atoms contain electrons, neutrons and protons. Well, I already know that, so that's brilliant. Extra bit of information there. So it says draw one line to link each particle to its correct relative charge. So I'm going to highlight the word one because that's important, actually one line from each. So if I look back at my sheets here, I've got the information right here. So if it says it's relative charge, if I'm looking at the relative charge, I've got protons are +1, neutrons are 0, and electrons are -1. So all I have to do is find the right one to link up. So electrons, -1 here. Neutrons are neutral. Protons are positive. There we go. And I know I've got those right because I can check that against the sheet I already had. Which of the following is the relative mass of a proton? So this one's talking about mass, whereas that talked about charge. So remember I said before, we have to be very careful at looking whether they're talking about mass or charge. So we're looking at the relative mass of a proton. So if we have a look at here, the relative mass of a proton, 1. Let's just find the one that says 1. We put our cross in it. Easy. Next one. Figure 3 shows information about the charges and relative masses of the 3 subatomic particles. So charge, positive, neutral, negative, relative mass. Okay, so it says use the information to give the names of particles A, B and C. So I want the names. So I'm going to recall here that the names of the subatomic particles, I'm going to write on here are protons, neutrons and electrons. Now I know we've just had a question about this just previously, but it's unlikely to have all questions that have the same kind of topic in one exam paper. I've just grouped them together to help us do some revision. So protons, if we look at that, let's look at the charge first of all. So go back to here, protons, the charge is +1, positive. So I look at this, protons, positive. So I think that proton is there. Let me just double check the relative mass. Yes, it's 1. So A must be proton. Neutrons, we're going to look at neutrons. They have no charge and a relative mass of 1. No charge and a relative mass of 1. Neutron. And so therefore, by process of elimination, that one must be an electron. We know electron doesn't really weigh a lot, so that must be correct there. So electron. Okay, question number 3. The elements beryllium, magnesium, calcium, strontium and barium are in group 2 of the periodic table. Okay, we could check that if we wanted to. We're just going to take that as true. States how the position of barium in the periodic table shows that it is a metal. So something about the position, highlight the position of barium shows it's a metal. So let's get my periodic table out. So barium, I'll find barium. Have a look. Barium. Oh, it's very hard to find. Can anyone else find it? Well, I mean, I would say, oh, there it is. I found it. Barium down here. If it's a metal, we know metals are on the left-hand side of the periodic table. So actually, we don't even necessarily need to find it because we can infer that if it is a metal, it must be on the left-hand side. So it is on the left hand side. Brilliant. Next question. The elements beryllium, magnesium, calcium, strontium and barium in group 2 of the periodic table. So that's the same fact as we had on question 3. Each calcium atom contains 20 electrons. That seems quite important. So I'm going to highlight the word calcium and 20 electrons. Which of the following is the electronic configuration of a calcium atom? Well, if it has 20 electrons, the electronic configuration must add up to 20. So let's just start with that. 2 plus 8 plus 10, that's 20. 2 plus 8 plus 8 plus 2, that's 20. 2 plus 2 plus 8 plus 8, that's 20. 8 plus 10 plus 2, that's 20. So it's not really very helpful for us on this one. Okay, so then we're going to have a look and remember how many electrons you can fit in each shell. That might help us. So I remember it's 2, 8, 8, 2. And you fill from the centre here and you fill outwards in that way. So let's kind of fill from the centre and see when we get to 20. So 2 plus 8 is 10, so it can't be there. Add another 8, so 8, 16, 17, 18. So it must be the full 2, 8, 8, 2. Okay, so let's have a look at that. It must be B, so that is 2, 8, 8, 2. Okay. Question 5, figure 4, shows a diagram of an atom of sulfur. So I'm going to highlight the word sulfur. That seems it might be important. So we've got a nucleus containing 16 neutrons, highlight that, and 16 protons. States why this atom of sulfur has an atomic number of 16 and a mass number of 32. Oh, okay, I remember we talked about this on our revision sheet. So if we have a look back here, so the mass number, so the mass is found in the nucleus. It's the protons plus neutrons. So I'm going to write that down for the mass number. So the mass is found in the nucleus. And it is the protons plus neutrons. So that equals, so 16 plus 16, which equals 32. That's that answer. That kind of ticks off that bit. The mass number is 32. It's found in the nucleus, and it's the protons plus the neutrons, and I'm adding them together. And then let's look at the atomic number. If we remember here, atomic number is the number of protons, which is equal to the number of electrons. So atomic number is the number of protons, which equals 16. Oh, moving over. So it's 16. Brilliant. So I've got that there. So I've just shown that it is 16 because that's the number of protons. That's the atomic number. And the mass number is in the nucleus. It's protons plus neutrons. So 16 plus 16 is 32. So the next question, give the electronic configuration of an atom of sulfur. Okay, so electronic configuration, I'll have to add up to 16 because if we remember, the atomic number is the number of protons, but it's also equal to the number of electrons as well. So whatever number we've got of atomic number, that's the number of electrons as well, just in an atom. So it must be the electrons must add up to 16. But actually what we could do is quite sneaky. We can cross-check there, but we can just look at this and we can look and count for each layer. So the first one has got 2 in, so that's a 2 there. The second one is 1, 2, 3, 4, 5, 6, 7, 8. So that's the next one. And then the third one has 1, 2, 3, 4, 5, 6. So it must be 2, 8, 6. And I can cross-check that in several ways, which is the beauty of chemistry, really. So if I go 2 plus 8 plus 6, that should equal 16. So 2 plus 8 is 10 plus 6, yeah, 16. Excellent. Okay. I can also then look at sulfur in the periodic table. So if I bring it back in an exam, you will always have a periodic table at the very back. So I found sulfur here. If I look up, it's in group 6. So that means it has 6 electrons in the outer shell. So I'm right. So I've put 6 on there, which is really good. I also notice I've got 3 shells. If you look here on sulfur, it is in period 3. 1, 2, 3. So actually I can cross-check in several ways. I know absolutely I have definitely got that mark there, which is awesome. And the last one then, Figure 4 shows the atomic number and mass number of 2 isotopes of argon. Okay, describe the structure of an atom of argon 38 and an atom of argon 40. So the structure, I'm going to talk about protons, neutrons and electrons. So I'm going to write protons and then neutrons and then electrons. So the protons, we know, we've said here, the atomic number tells you the number of protons. The atomic number is 18. So protons equals 18 in both atoms. Okay, because the atomic number is the same. I'm just going to write atomic number just so an examiner knows exactly, well, that I know exactly what I'm talking about. And so the electrons must be the same. If we look back on here, it says number of protons equal to the number of electrons in an atom. So the electrons must be 18 in both atoms. Okay, and then we've got the neutrons. So we know the neutrons is, if we look at this, the mass is protons plus neutrons. So mass is protons plus neutrons. So we know that mass number is the protons, so we need to take one away from the other. So that one will be 38, take away 18, which is 20, and that one would be 22. So the neutrons of, say, in argon 38, there are 20 neutrons, whereas in argon 40 there are 22 neutrons. Okay, so I'm having a look. Let's glance back at the question, make sure we've answered it all. It's out of 3 marks. So describe the structure of an atom of argon 38, an atom of argon 40. So I said there's protons, 18 in both atoms, electrons, 18 in both atoms, but hang on, I'm just thinking structure, I might add in a bit. So the protons and neutrons are found in the nucleus, and the electrons orbit the nucleus. I'm just double checking, making sure that I've got those marks there to make sure that there's no excuse for me not to get all of those marks there. And actually, if I look at the mark scheme, it says both have 18 electrons, we've got that. Both have 18 protons, and then in brackets in the nucleus. So you could have that, you don't need to, but we're making sure that the examiner knows that we know exactly what we're talking about. And then argon 38 has 20 neutrons, yes, we've got that, and argon 40 has 22 neutrons. So we have got that marking point there. So that is the end of our questions. Thank you.